Hi everyone. In this video, I am going to show you how to just do the model fitness criteria for structural equation modeling. So I'm going to use an example dataset with STATA software. So I do have already the dataset opened in STATA. So click on statistics and go for structural equation modeling and model building and estimation. And here in the interface, I need to click on the rectangular shape to draw observed variables here. So since I do have 6 variables, I need to click on the draw a 6 boxes over here. Okay, we can put the boxes as required. Okay, now let me choose the variables within each box. Okay, over here maybe PTSD, over here and depression, and over here maybe anxiety. Okay, and maybe over here fear of birth, and lastly over here maybe social support. So I need to draw a path again in order to just show the cause and effect relationship. So click on the add path. PTSD could have an association with functional status, and over here again, okay, so we can draw as we require. Fear of birth again with all the mental disorders and the functional status. Social support could have an association with this. Okay, the depression, PTSD, and then finally with Huda's score. Okay, yeah, let it be enough. Okay, so now let's estimate. Click on estimate and then estimation. The estimation method should be maximum likelihood method, and then click on OK. So all the parameters has been estimated, and let's see the result over here in the STATA window. So we can see the direct effect of all these variables on the outcome variable with their beta coefficient, standard error, z statistics, the p-value, and the confidence interval. So what I'm going to show you here is how to just see the outputs of the model fitness criteria. Our model should be well fitted with our data. So there are criteria that we have seen in the previous video. All these criteria, the chi-squares, the AIC, the BIC values, the coefficient of determination, the root mean square error of approximation with this cutoff level, comparative fit index with this level, Tucker-Lewis index with this level, and standardized root mean square residual having less than 0.06 cutoff level. So how do we see the output of this model fitness criteria while we are doing structural equation modeling? So we say our model is well fitted, or it does have a good fitness when it fulfills all these cutoff levels of criteria. But if not, we need to just respecify the model. So once we have already estimated the model, we should again click on estimation and go for goodness of fit is over here. Click on goodness of fit, and we need to choose overall goodness of fit. Overall goodness of fit, because we are going to test the overall goodness of fit of our model. So click over here, and a window will appear over here. It says goodness of fit statistics, and this window might be empty for the first time when you open the window. It says statistics to be displayed. If you click over here, there are lists of model fitness criteria that we have seen in the PowerPoint. So we need to select all of the above. All the model fitness criteria should be displayed in the output. So now hereafter click OK and go to the STATA window. So here is a command that we should use if we are interested to use the command syntax to display the model fitness criteria. We can use this command syntax, So here are the lists of the model fitness criteria. The first one is the chi-square, having this value, and the p-value is 0.000, which is much less than 0.05, which is statistically significant. But to say that the model is well fitted, the chi-square test should be non-significant. Okay, but the statistical significance of the chi-square by itself could not tell us the model inappropriateness. The chi-square could be statistical significance because of the higher the sample size. In this example dataset, I do have 775 sample, and structural equation modeling by its very nature require at least 200 to 400 sample size by rule of thumb. So if the sample size is larger than 400 sample size, 400, so that it means the sample size is larger. So the larger the sample size, the higher the probability of the chi-square to be statistically significant. So the statistical significance of the chi-square test by itself might not be because of the inappropriateness of the model. It might be due to the larger the sample size. So we could not rely only on the chi-square test. So we should go for other criteria for model fitness. So let's proceed. Now RMSEA is found to be 1.447. RMSEA should be less than 0.08. But this is indicating that the model is not appropriately well fitted with the data. Okay, with its confidence interval and with its p-value. The AIC and the BIC value, AKK information criteria and the Bayesian information criteria. And actually to use or to judge the level of this AIC and the BIC, we need to develop an alternative model for this similar research data, in order to say that this AIC and the BIC is lower than for this model than the other model. We need to have a comparison model. So we can draw a different model, having a different connection. So the lower the AIC and the BIC is the better that model. Okay, let's proceed with this comparative fit index and the Tucker-Lewis index, that is CFI and TLI. All of these criteria are less than 0.9 or less than 90%. Okay, so that the model is not well fitted. Okay, SRMR, again it is 0.246. It should be less than 0.06. And the coefficient of determination, it is around 30% or 29%. It should be at least greater than 50. So all these model fitness criteria are telling us our model is not well fitted with our data. So the goodness of fit of our model is poor. So what should we do? We need to re-specify the model. We need to redraw the model. That is why in the definition of the structural equation modeling, it has been said that structural equation modeling is a flexible statistical estimation technique. It is flexible. Always we will go for and back. So we need to try again and again in developing our model. So we need to go for a re-specification of the model. So for the interest of demonstrating how to re-specify and how to get a well-fitted model, now I have a plan to open another data set. Here I do have a data set with a different data variables, and I'm going to open a model that has been already developed, another model. If you have developed a model, you can save the command of that specific model and open it again in order not to draw again and again. So it might take a few seconds to open because there is a complex relationship between the variables, you know. Okay. Click. By the way, when your model is just too wide outside of the window, you can just click over here, fit into the window. So by clicking over here, just your model will be fitted within the model. Within the window of the interface. So here is a model that has been developed before in a certain publications that have been published, maybe in archives of publications. Okay, so I should clear these estimates. I have already cleared, so that I do have a data set over here, and from this data set, this model have been developed. So let's assume that we have re-specified or redraw or redeveloped the models that we have tried before. So now this is another model that have been re-specified or redrawn. So now I'm going to estimate the parameters. Click on estimation and estimate, and maximum likelihood estimation is chosen, and then click OK. So we can see the result over here in the window of STATA to see the details of the results, but the summary of the results has been also displayed in the path coefficients over the diagram. So now I am going to just display the model fitness criteria again. Click on estimation, go for goodness of fit test, and choose overall goodness of fit. Click over here. And then as before, over here we need to choose all. And actually we need to just choose it once. Okay, click OK. And we'll go for a STATA window to see the result of the model fitness criteria. The chi-square is again statistically significant here, but we do not rely only on chi-square in order not to be misleaded. RMSEA is 0.1, which is much closer to 0.08 over here. If we approximate this 0.08, obviously it will be 0.1. So this RMSEA is closer to the cutoff level. Okay, let's proceed to other criteria. Here is a confidence interval for this RMSEA. The lower bound, the upper bound, and then the p-value is given here. Okay, the information criteria, AIC and BIC. Now we can compare the AIC and the BIC value of this model with that of the AIC and the BIC value of the model that we have estimated before. So, and when you compare the AIC and the BIC value of this model with the previous one, the value of this AIC and the BIC will be lower for this model because this is a better model. By having a look at on the CFI and the TLI, look at over here. CFI is almost 99, almost 100. TLI is almost near to 95, greater than 0.9. SRMR over here is 0.022, which is much less than 0.06. And the coefficient of determination is approximately 70%. So in this case, this model is appropriately well fitted with the data because all the model fitness criteria except the chi-square are indicating the model is well fitted appropriately with the data. So the goodness of fit of the model is really very good. But why the chi-square is not indicating? Because it is because of the larger the sample size that we have. So this is a way how we can display the model fitness criteria of the structure equation modeling and how to judge whether our model is well fitted or inappropriately fitted with our data. So this is what I have to show you in this video. Thank you again for watching. See you in next videos. Bye bye.